Hello, my name is Cindy Lou Skipper,
And my name is Diana Valenzuela Davila.
and we are both first-year graduate students aiming for master's degrees in Earth and Environmental Science.
Our poster is titled Comparing Burial Ages for Quartz and K Feldspar Grains from Permafrost Rivers in Alaska.
Alaskan rivers can melt permafrost and erode riverbanks, which releases trapped organic carbon, potentially contributing to greenhouse gas accumulation. Samples collected from the Koyukuk and Yukon rivers in Alaska were processed and analyzed to determine the burial ages of the sediments. With this study, we are able to compare the results from quartz and K-feldspar and determine if both minerals give consistent ages or if we need to modify our approach in future work at these sites.
Optical stimulated luminescence, or OSL, dating gives the amount of time that has passed since a mineral grain, such as quartz or K feldspar, was exposed to sunlight before its burial in the natural environment. Luminescence dating frequently results in significant age uncertainty in partially bleached environments due to the challenges in identifying the population of interest for age calculation in comparison to well-bleached sediments. The OSL signal of quartz is frequently favored for luminescence dating over the signal of K-feldspar environments with limited chances for sunlight exposure because the OSL signal of quartz has the ability to bleach more quickly in response to sunshine than the signal of K-feldspar. Alternatively, K-feldspar signals can have an inherent brightness that is independent of sensitization. As a result, in some cases, single grains of K-feldspar may be preferable to quartz. Below is an aerial picture of the area where the samples were taken. As you can see, meandering rivers channels have been abandoned or reformed.
For our materials and procedure, metal tube was reused to collect sediment samples, and the ends were immediately covered with rubber end caps to prevent sunlight from touching the freshly removed grains. Here is a diagram which shows the repeated process of grains being bleached in sunlight or heat and then being deposited, which allows for the accumulation of the luminescent signal. Once the samples are transported to the dark lab, the end caps are removed and a small amount of sediment from either side of the tube is scraped off to ensure that none of the grains being measured could have been partially bleached during sample collection. The inner material is sieved twice in order to isolate a known grain size. In this case, we isolated grains between 100 and 150 micrometers. The grains are then added to heavy liquid and placed in a density separation chamber. This will help to further isolate the targeted mineral. After the grains have been rinsed and dried, they will be treated with hydrofluoric acid to eat away at any undesired materials. The pure mineral separates can be placed onto discs for analysis in the luminescence reader. Single grain discs are shown in the figures 1A and 1B. Each disc has 100 wells. Grains are loaded into each well, and the reader uses the 3 larger wells on the sides to orient the disc correctly. For single aliquot, a drop of oil is placed onto the disc, and some grains are added on top. In figure 1C, you can see an outline which the oil left after evaporating from the slide. Below each picture of the discs are their corresponding equivalent dose graphs. Single grain K feldspar measurements show low standard deviation, as do single aliquot quartz measurements. Single grain quartz in the center shows a larger standard deviation.
Single grain K feldspar measurements give a consistent minimum burial age. Single grain quartz measurements were unreliable due to the low response rate. Single aliquot quartz measurements were more efficient as the luminescence reader can measure signals faster when the single aliquot method is used. An analysis revealed that both single grain K feldspar and single aliquot quartz provided similar estimates of burial ages. Single grain quartz, although it produced an estimated age of burial, was not consistent with either single grain K feldspar or single aliquot quartz. This is likely due to the number of grains that were respondent, in this case, 1%. To offset such discrepancy, single aliquot quartz was run, as it provided both high levels of precision and increased accuracy. Moving forward, single aliquot quartz should be considered over single grain quartz for this particular environmental deposition.
Thank you to Carissa Cordero and Ayush Joshi for their support and suggestions. Thank you also to the UTA Earth and Environmental Sciences Department.
We hope you enjoy our presentation. Thank you for listening.